Good afternoon. Good afternoon. In a weird turn of events, I'm streaming off schedule a bit, mostly because I want to push forward with my project that I'm working on. I should probably tell you who I am. I'm Gabe, the O-Scope Wizard. I almost forgot that little part. You have joined me in the Techno Lair for a quick stream, nerding out together. I'm going to set my timer. We try to hang out for about 25, I say 20 minutes. We start with 20 minutes and then we kind of drag on to whatever amount of time it takes. 20 minutes, set the timer. Let's set up the show for what we're going to do. We have been working on creating a subwoofer in a 5-gallon bucket, wireless, a wireless subwoofer in a 5-gallon bucket. Right now, I'm working on trying to get signals into that subwoofer that are in the subwoofer frequency band. So that means we're trying to create low-pass filters, and we are doing this out of various R's and C's. And today, we're going to use OpAmps, so active filters. It's very exciting. On the last stream, I was struggling a little bit with math. Now, math can be hard. Math can be tough. Also, suddenly I have a computer that's yelling at me on the side there. And while I was trying to do the filters and the filter calculations and the transfer functions, I remembered back to my time in college and remembering how little I cared for transfer functions at the time. They are very powerful and you can do all sorts of things with transfer functions. I'm just not that good at it, honestly. So once you get out of first order filters and you go up to second and third order filters, you start getting so many more S's and which is 1 over 2 pi f, and you have to figure out what the XC's and Thevenin's equivalents. And you know, there's a tool for people like me that just want to simulate the circuit, and it's a circuit simulation tool. So we're going to use that today. And we're also going to use an OpAmp to make an active filter. So let's get into the actual show. So let's start with, I always forget this part, which is the agenda and the notes and basically the title of the show. So today we're going to do circuit simulation. Circuit, is that right? Circuit simulation. Am I spelling circuit right? I always, I before E except after C. Circuit simulation. And, oh, we're also going to do this. Splitting power supplies into positive and negative rails. So we're going to do two things. We're going to make circuit simulations. Oh, let's save that. Save it. Let's get me out of the way. Can we get me out of the way? Where am I? Here we are. There we go. Oop, nope, nope, nope. There we go. Get me out of the way. I'm out of the way. I'm out of the way. We're going to do circuit simulation and splitting power supplies into positive and negative rails. Why are we going to do that? Great question. Who cares about positive and negative rails? We've been doing everything so far with, let's turn off my titles. You know what? And now we will start our timer. We'll start our timer, keep us on track. I think everything's working amazingly, if you can believe it. Positive and negative rails. What are we doing here? I probably just need to look at the browser, don't I? Browser. Oh, nope, not that one. Not that one. Nope, not that one. That one. That's the one we want to look at. The reason why we need to look at positive and negative rails is our OpAmp wants a positive and negative rail. And I have been doing everything in our project so far with a single 12-volt supply that I had wired from ground to 12 volts. I go into my data sheet for this OpAmp. The OpAmp we are actually using is the TL072p. I chose the TL072p because A, it's a dip package, and B, it has 2 OpAmps in a single tiny 8-pin package, which is perfect. because I can make multiple gain stages using just one op amp. So you have an in plus and an in minus and then an output. But if I go down to my op amp, is this the 7? Yep, this is the 7.2 right here. I notice that I have VCC plus and VCC minus. And when I wired it up from VCC plus to ground, it did not like my audio input. Now, why is that? My audio input goes above and below ground. It's a positive and minus signal. That's the way it comes into my board. And anything that goes below the negative reference point on this chip just basically clips away. It's gone. It doesn't work that well. So I need to make sure that if my signal goes below ground, the reference level for my op-amp is also below the ground. So how do I do that? That is a great question because all I have is one 12-volt supply. And what I really need is a positive 12-volt supply and a negative 12-volt supply referenced to a single ground plane. One of the cool things that I can do, though, is use some passive components to split it up. If I go into my circuit simulator, let's figure out the circuit that would actually work. So I've downloaded a simulator. I told you we were going to get away from math and we're going to do some circuit simulation today. My circuit simulator that I grabbed is Easy EDA. I don't know if that's a good one or not. It's so far been pretty good for me. And the best part, it was free to download, so I could quickly try it. I want to make a new, let's make a new, can I make a new sheet? So a blank sheet. So let's see what I have. Go into my library. I got a VCC right here. And I have a ground right here. And that's how I had everything wired up. Ooh, kind of wired that crazy. And it's 12 volts right here. I don't know, can I tell it? I think there are some components in here. I know there's components in here that I can make 12 volts. Does it say? I'm not sure. All right, so one of the tricks to split your supply up is to use some resistors and capacitors. So what I have actually wired up on my board is a couple of resistors. So I have a resistor here, and then I have a resistor here, and then I have a capacitor in parallel with the resistors, or I have two capacitors in parallel with the resistors. Ooh, I know that's going to bother some people and me if it's not lined up. Line up. Line up. Does everybody use their tools with snap to grid? Whatever tool it is, I'll tell you what, if the tool has snap to grid, I'm using it. I just want to be on the grid, which is, it's ironic because everywhere else I want to like do my own thing, man. Yeah. Weird. That's just a little insight into me. I want to not be snapped to the grid, and yet I can't help it. Oh, and I drew that line a little bit wrong. So what we're ultimately trying to do is use our resistors and capacitors to take this single 12-volt supply and make a positive and negative supply out of it. So one of the things that I had to do with my supply is if I turn on my webcam, let's turn on my webcam here. I think my webcam is super zoomed in to my, super zoomed into my op amp, which we'll get back to. I turn on my webcam and look at my supply. I think I can even come around here. So you can see I have positive, negative, and I had ground. So previously I had this ground lead tied to my negative because I wanted my supply to be referenced to ground. But to pull off this trick that I'm doing, which is splitting the supply in half, I have to pull that reference off because I can't raise the entire reference of the planet, but I can use some components here to split my supply in half, as long as my supply is not already referenced to ground. If I go back to my monitor, I took out this ground reference and just replaced it with a reference that wasn't ground. You might call this negative. That's going to be my negative voltage. And what I did is I made I think the people in the biz might call this virtual ground on my board. If I continue out my connections, a virtual ground that went through here, all the way. There we go. Now, what I have here, if I started with a 12-volt supply to ground, I now have a positive 6-volt supply and a negative 6-volt supply, as long as all these components match their values. And actually, on my board, I used 33 kilo ohm resistors. Why did I use such a high resistance? It's because once you hook this up, there's going to be current flowing through these resistors, and I just wanted to keep the current as low as possible. And I used 47 microfarad capacitors. Now, if I have hooked it up properly, I should end up with a positive and negative supply. Right here, we can see it. We'll save this sheet. Now, let's switch back over to my webcam and see exactly how I wired that up. Follow me. Think we got it here? Yes, right here. Follow me, come on. We're gonna check this out. I have, first of all, not plugged in my power supply while I'm pointing at stuff. I have my 33 kilo ohm resistor right here. That's the top one. And then I have the bottom 33 kilohertz resistor, 33 kilo ohm resistor. Then I have my two capacitors wired so that the positive side goes to the bottom negative lead and the ground side of the capacitor goes to my virtual ground. Same for up here. Capacitor positive lead goes to the positive voltage and the negative, or the ground side of the capacitor, goes to the virtual ground. And this center line right through here, that is my virtual ground, my new virtual ground on my board. I have a handy dandy multimeter that I think I can actually use to make some measurements. Let's plug it in and see what my voltage is that I read. All of this to try to use an op-amp. It is amazing. I thought it was going to be super simple and just like plug it in, and then it wasn't working quite right. And I was trying to figure it out, and I realized, you know what? I think I do need that positive and negative voltage rail. Okay, so if I measure across the whole thing, what voltage do I measure? About 14.88 volts. So my 12-volt supply up there is a little hot. That's okay. Now, if I go from the positive side to my virtual ground, I'm getting, that look like 3.7 volts, 3.7 volts. And if I do virtual ground to the negative side, getting negative 11 volts. Kind of crazy. I thought it would be a little bit more even. In fact, yesterday it was a little bit more even, but I don't know. Positive 3, negative 11. That's kind of wild. We're rolling with it. We're rolling with it. But I did have to rewire the references on my whole board. So now ground is now a virtual ground and not truly tied to earth ground, for better or worse. I do have my little op amp. So what I thought I would do today, after explaining virtual grounds and references and everything, let's go back into my simulation tool and see if we can match some simulation to some measurements. We're going to measure one passive filter, and then we're going to measure our active filter, and we're going to simulate them and see if the simulations match the measurements. Very exciting. Okay, back into Easy EDA. Let's go to my sheets. I have a bunch of sheets here. Let's go to the passive filter sheet. Okay. So I have a couple of filters here. I had a third order filter that I just plugged in to my simulator, but ultimately I'm going to just do the bog standard RC filter because I can put it on the board really quickly. 10 kilo ohm resistor and a 100 nanofarad capacitor. I can go to simulation in Easy EDA. I can set up my simulation. I want to do an AC analysis. If I look down here, I've actually already defined an AC analysis to go from 10 ohms to 10,000, or from 10 hertz, 10 ohms, 10 hertz to 10,000 hertz and do 1,000 points. So that's a lot of points on there. I'm going to run my simulation and we should get the V first order. So if I look back here, I can see that my probe is called first order. And here is my first order. And I can hide the phase for now. I think I can actually hide phase. So I'm mostly concerned with amplitude for now. So where's my 3 dB point? So if I go down to 3 dB, it's about 158, 160 hertz. So 160 hertz in simulation. If I was to wire that up on my board, can we make that match? I think, as luck would have it. Let's see if we can see. Pull these out of the way. I have right here a 10 kilo ohm resistor and a 100 nanofarad capacitor. We're going to see if this matches my simulator. It's always good to just, trust, but verify. In fact, a lot of test engineering is about verifying. In fact, all of test engineering is verifying the designs that design engineers have created, making sure what they designed and thought would work actually does work. So I am probing both V in right here, and I'm probing V out right here. I have my Polyplot software somewhere. Let's get my Polyplot software running. Polyplot software running. Here we go, Polyplot software. I'm gonna load a setup. The O-Scope Wizard low pass filter. Let's crank up the voltage to 2 volts. And I think we can just hit start. So I have it wired up like this, continue. Look in the back, you can see the scope is working away diligently. Looks promising. What's the Polyplot say? Okay, here's my, the red is my amplitude. If I go over to the table, I can actually see my gain. My gain starts at around 0, stays at 0, which is good because it's a passive filter. So 0 gain is about what you can expect. -2, so this will be my 3 dB point, 128 hertz instead of 160 hertz. Now, that could be a mismatch of my components, but in fact, it is definitely a mismatch of my components. So I have an ideal 10K and 100 nanofarad capacitor in there, and I could change the component values to see that they do match. But I wanted to go over to the OpAmp. Let's see if we can make an OpAmp work, because we've blasted through about as much passive filtering as I can stand. What I would like to do is, first of all, I'm going to measure this op-amp. So I've put in an op-amp circuit here that is two, uh-oh. Can we just grab the, there we go. I'm going to delete this line here. Right now, what I have wired on my board is this op-amp circuit, not this one, just the other one. If I grab all this, and I don't know how to use this that well. Does that work? No. Never mind how to drag that out of the way. I'm going to put this probe, though, on this probe point for sure. I think I am. Oh, my goodness. Maybe I am. There we go. Get it on the probe point. So I have a 10K resistor into a 100 nanofarad capacitor, which connects to the out, and then a second stage. So this is a second order low-pass filter using my TL072, so 1/2 of the TL072. If I go to my TL072 webpage, let's right here, I've wired it in to be non-inverting, so I have tied V out 1 back to V in negative, and then I have put the input in all filtering stages on input positive. And that leaves me an entire second op-amp to use for a second stage of filtering, which I'm pretty stoked about. If I go in here, as opposed to trying to work through all the formulas of this active filter, I can just simulate it. Again, from 10 hertz, now we're going to go to 20 kilohertz, which is the full hearing range for humans, and 100 points. I'm going to hit go, and hopefully it works. If it doesn't, then yeah, this gets crazy here. I need to take this and delete it, and then just put a new one down. I don't know. I'm not here to debug software. I'm probably using it incorrectly, I would say. I don't know. I'm again, O-scope wizard, not EDA, easy EDA wizard. Just trying to use the tools I have, like any engineer. Okay, so this guy, according to this, should get out to about 100 hertz and then roll off pretty steeply. So it's a second order, so it should roll off at about 40 dB per decade. What did we say? 100 and 110 hertz? Oh, 100 and 105, 100 hertz, somewhere, 100 hertz. Does my simulation match my measurement? I do not know. But what I do know is I can look it up really quickly. So let's do that. I have this red cable, which represents my audio input. It needs, oh my goodness, oh my goodness. Ah!
5 minutes remaining!
5 minutes remaining, but we're going to measure this op-amp. We're going to measure it and see if it matches. I think it will. Well, I haven't actually. It's a good question, will it? The passive filter was pretty close. Will the active filter be close? Let's see if I can get a little bit more light. A little more light. There we go. A little more light. So I need to have this guy right here is one 10K resistor. Have a couple of 100 nanofarad capacitors. Let me make sure they're 104. Let's turn this a little bit more so you can follow. 104 and 104. So 100 nanofarad capacitors, two 10K resistors. Does that match what I had in my simulator? think it does. 10K, 100 nanofarad, thumbs up. Our simulation matches what we've wired up. At least, I think it does. I think it does. I have them wired up. I think we can even get a better, yeah. So this cable, this purple wire is V out. It's actually going to be my V out. So I'm going to put it down here. I'm going to put my probe on V out. And then I'm going to put the negative side of my probe to my virtual ground. Virtual ground. I need to power. I need to power my OpAmp with my fancy new split power supply, though. I just remembered. So in order to do that, I need to put the positive rail, the VCC plus, and the negative rail. So this is V negative, the VCC minus. So I'm going to do some really long wires there. Now we got that wired up. Done. Plug it back in. I think I'd have more confidence. Just plug the thing. Just plug the thing in. These op amps are tough. They are pretty tough. The TL072 is pretty doggone tough. Does it work? Does it work? Let me get this extra little component out of the way. A little extra random capacitor. Oh, I need the input. Input. This red cable goes to the input resistor right there. So that 10K resistor that cranks it all up. Now, let's run another Polyplot really quickly. Polyplot. We can save our passive filter to memory. Did I have it? To memory 1, so we can remember what it looked like. We will continue. All right, so that's good. It's sitting around 0 because I have the circuit set to unity gain. No gain. And it follows. This is my frustration. In a practical sense, this is an actual second order filter. But despite that fact, let's see, -3, 128, and we said it should be around 100. So its cutoff frequency isn't quite as low as we designed for. This is where simulation versus measurements aren't lining up. This second order filter characteristic is following almost exactly my first order filter characteristic. And I wonder if I went out farther, if I made my stop frequency higher. So if I made it 20 kilohertz instead of 10. I don't know if it'll draw. Oh, I blew it up because I think I had my memory there trying to draw lines that couldn't do. Oh well. Oh well. So we used a circuit simulator to make some simulated measurements to get some simulation data. We compared that to actual measurement data. Oh, what do we got? We got somebody in the chat. Ooh. Non-inverted and then pointed to pin 2. Okay. So the chat's wondering if I have wired this as inverting or non-inverting. I believe that I have wired it as inverting. Let's just real quick. Let's real quick. I believe we have. Oop. Oop, oop, oop. That is a good question, though, because we want to make sure that our simulations match our measurements. Otherwise, it just loses all value. I have the input going here to, this is my input resistor going to pin 3 and that mess of wires down there. And then I have a tiny little jumper from V out to V in negative. So I think I have it as non-inverting, although the frequency response, inverting, non-inverting, shouldn't really change, I don't think. But what is frustrating me is that I expected a steeper roll-off from the second order filter. I expected, 40 dB per decade. And from 1,000 hertz to 10,000 hertz, it is following the first order frequency characteristics. Now, one other thing that I might do is do staggered resistors. So I have my resistors and capacitors all equal. So what I could do is do a much lower value for resistors and capacitors. So I could say 10K 100 nanofarad and then do a 1K 10 nanofarad to handle the higher frequencies and hopefully get a second stage, get that second order filter effect. So the higher order filter. I want a steeper slope and I can't seem to get it with these analog components, which brings me to my final point. This is a wonderful place for DSP. Ultimately, I think my wireless subwoofer will either have a Raspberry Pi or a microcontroller inside of the bucket with the subwoofer. And that component could just have DSP built in. And with that DSP, I could just build in whatever crazy roll-off I want. So yeah, I think what I'm going to do next time is one more experiment with the OpAmp to see if I can get a steeper roll-off in the analog world. And then we're going to switch over and check out the world of audio filters and DSP using Raspberry Pis and microcontrollers. So I think that'll be cool. That'll be cool, man. That'll be cool. I'm going to hang out in the chat. I don't know all the nerds in the world, so please share this with a nerd in your life because I would love to meet them. I said that I will hang out in chat a little bit too soon, but I'm still going to hang out in chat afterwards. Thanks for watching. I appreciate it, and I will see you guys next time. Bye.